Welcome to this deep dive. We are jumping straight into really a fascinating corner of Formula One right now. We're looking at cutting-edge potential technology, stuff that could dramatically change, well, one of the most fundamental things, managing tire temperature.
Yeah, and what's really interesting here, I think, isn't just the tech itself, cool as it is, but the whispers,
Great.
the hints that this isn't some sci-fi concept for the distant future.
Right.
The sources we're looking at, they suggest it could actually be legal for the 2025 season.
That's the hook, isn't it? So for this dive, we've basically pulled together insights from some interesting material discussing a concept around Peltier devices.
Okay.
We've got mentions of perspectives like from someone called Dr. Obbs and some context that seems to stem from maybe a tweet or reporting by John Noble.
Gotcha. So our mission here really is to figure out what these Peltier things actually are.
Yep.
Then explore how they could, fundamentally shake up F1 tire strategy during a race. And maybe the biggest part, understand why they might currently sit in that classic F1 gray area.
That regulatory sweet spot. Or maybe nightmare, depending on who you ask.
Ah, exactly. Potentially getting a green light for next year.
And I think the big takeaway right from the start, this isn't just some wild fantasy.
Mm-hmm.
It seems to be considered technically achievable.
Yeah.
And if a team can actually pull it off within the rules, well, it's a perfect example of F1 innovation, isn't it?
Oh, absolutely. It's finding clever ways to interpret, maybe exploit the rule book for that edge.
That tiny performance advantage everyone's chasing.
Okay, so let's start right at the core then. Why is tire temperature so critical in F1? We hear about it all the time. Tires aren't in the window, that sort of thing.
It's basically everything. It's the connection, the only connection between that incredibly complex car and the track surface.
Right.
The grip you have, it's almost entirely dependent on getting that rubber, that compound, into its happy place, its optimal temperature window.
And if it's too cold?
You're just sliding around, no bite, no grip. But if it gets too hot...
And performance just falls off a cliff, right? The rubber overheats, degrades, wears out way faster.
Exactly.
Wow.
And managing that tiny, constantly shifting temperature window, it's a battle from the moment the car rolls out.
Yeah, the source material we looked at even points out that some recent FIA activity technical directives about other ways teams were trying to manage temps. That actually kind of stirred the pot, got engineers thinking, okay, if that's not allowed, what else could we try? Maybe push them in this direction.
So one door closes, another potentially opens. Fascinating. Which brings us neatly to the tech itself, the Peltier device. What exactly is this thing?
Okay, so at its heart, it's what's called a thermoelectric cooler. It's solid state, which is important. No moving parts like a compressor or a pump.
Thermoelectric. Okay, break that down a bit. How does it actually function?
The principle is actually quite neat. You apply an electric voltage across specific semiconductor junctions inside the device.
Right.
And it causes heat to move. It pumps heat from one side of the device to the other. So one side gets hot and the other side gets cold.
Okay, simple enough.
And what's really useful, potentially for F1, is you can just reverse the direction of the electric current. And the hot and cold sides flip. The side that was getting cold now gets hot, and vice versa.
So, hang on, it's like a tiny reversible heat pump that just uses electricity. No fluids or anything.
Pretty much, yeah. That's a good way to think about it.
That's clever. I think the material mentioned examples, didn't it? Things outside F1 where these are used.
It did. Things like cooling CPUs and high-performance computers, those little portable electric coolers or fridges you can get.
Oh, yeah, I've seen those.
Or even in some cars now, climate-controlled seats use them for heating and cooling.
So it's established technology then, just maybe being applied in a very, very different context here.
Precisely. And that bidirectional capability of the heating and cooling, that's really the key to why it's apparently generating so much interest for F1 tires.
Okay, let's dig into that. This dual power play, as the outline calls it. How could teams actually use these on an F1 car? The sources suggest two main ways. First up, heating. When would a team want to add heat to a tire during a race or session?
Well, think about all those times when tires naturally lose temperature, right? Those crucial moments, like the warm-up laps before the race starts, or that absolutely critical out lap just after you've pitted, you need grip immediately.
Can't be sliding around losing seconds.
Exactly. Or even when you're stuck behind a safety car for multiple laps, just crawling along, the tires cool down a lot.
And a Peltier device, integrated somewhere, could actively fight that cooling, push heat back in.
That's the idea, yes. If they're embedded, say, In the wheel rim or near the tire bead, they could actively transfer heat into that structure. It would help get the rubber back towards its optimal working temperature much faster than just relying on driving hard or waiting for brake heat to soak through.
Okay, makes sense. That's heating for when they're too cold. What about the flip side, the cooling scenario? When do tires get too hot?
That's the other big headache, right? Overheating, you push really hard for a long stint, maybe it's a hot day, high track temps.
Yeah.
The tire surface, the whole carcass just soaks up heat. They go past their best temperature, grip starts to fade, and they degrade really quickly. That's when you hear drivers saying the tires are gone.
And flipping the current on these Peltier devices could actively draw heat out, like a little fridge for the wheel.
Essentially, yes. They could pull heat away from the critical tire surface or maybe the inner rim structure, moving it to the hot side of the device, which then has to get rid of that heat somehow.
We'll come back to that heat dumping problem.
We will. But the idea is this could help manage or at least delay that performance drop-off you get when tires overheat. Keep them in the window for longer.
Wow. Okay, so you potentially get active, real-time, on-demand control. Heat them up, cool them down lap after lap during the actual race. That's a level of control they just don't have right now. Not really. Not with this kind of responsiveness. That sounds, well, incredibly powerful, strategically huge.
It really does, but, and it's a big but, as the sources rightly point out, taking this concept and making it work reliably on a 200-mile-an-hour F1 car, that involves some serious engineering challenges.
Right.
We saw that quote from Dr. Obbs, didn't we, calling it 1,000% doable technically, which is quite confident.
Yeah, very bold.
But even he apparently flags up the practical difficulties.
Yeah, doable in a controlled lab is one thing. Making it survive the vibrations, the heat, the G-forces, the pit stops, that's another game entirely. What are the big practical problems they'd face?
Well, placement is massive. These devices are small, sure, but where do you physically put something that needs electrical power fed to it, needs really good thermal contact with the wheel or tire assembly to actually do anything, and needs to somehow get rid of its own waste heat, all in that incredibly cramped, highly stressed, vibrating environment around the wheel?
Yeah, not much spare real estate there.
Not at all. The material we saw mentions ideas like embedding them right into the carbon fiber of the wheel rims themselves, or maybe integrating them somehow into the brake ducts.
Which immediately makes you think, how would the FIA even inspect that?
Yeah.
And how would it survive impacts or wheel gun action?
Exactly. Questions of visibility, scrutineering, durability, they all come up. And then there's power. They aren't passive devices.
Right. They need electricity to work, potentially quite a bit of it if they're moving significant heat. Where does that come from?
Good question. Tapping into the car's main electrical system, maybe drawing from the ERS battery pack, which is already under strain, or maybe even needing a dedicated small power unit just for this system. And then you've got to run the wiring. It needs to be robust, shielded, hidden away, probably routed through the suspension components. And again, compliant with all the existing rules about wiring and electrical systems.
Okay, so placement is tough. Power supply is a challenge. What about the heat they generate? You said one side gets hot. Where did that heat go?
That's the third big one, heat dissipation. The Peltier effect moves heat. It doesn't make it disappear. So the side of the device that's getting hot, whether you're heating or cooling the tire, there's always a hot side somewhere, needs a really efficient way to dump that thermal energy into the surrounding environment.
Otherwise, the device itself overheats and stops working, or worse.
Precisely. The source material suggests ideas like using the complex airflow on the wheels and in brake ducts, maybe integrating tiny, lightweight carbon radiators specifically for this system, or somehow piggybacking onto the existing brake cooling system to carry that heat away.
All sounds incredibly complex. Lightweight, efficient, robust. The usual F1 engineering triangle.
You got it. So technically feasible, probably, but integrating it successfully into the extreme F1 environment. That's the real engineering headache.
Which leads us perfectly into the bit that probably has team principals losing sleep. The regulatory chess match. Is this actually legal? Or, more accurately, why is it even being considered potentially legal?
Yeah, this is where it gets really F1, doesn't it? This is where context from people like John Noble, his reporting, or maybe that tweet mention, seems crucial.
Okay.
The implication from the source material is that earlier this year, the FIA issued some technical clarifications, TDs, related to tire cooling. They were trying to shut down some other methods teams might have been exploring.
Right, closing loopholes.
Trying to, yes. And apparently a whole bunch of clever ideas got explicitly ruled out. But critically, This specific concept, using Peltier devices in this way, it seems it wasn't on that initial FIA banned list. It sort of survived the first wave of regulatory scrutiny.
It slipped through the net, so to speak.
Yeah.
Interesting. So what existing rules does it still have to navigate? It can't be a complete free-for-all.
No, definitely not. The material notes that while there isn't apparently a specific line in the rulebook right now saying thermoelectric coolers on wheels are banned, there are existing rules, bans on things like, say, active tire warmers being used on the grid after a certain point in the procedure, and there are general limitations on active systems that influence the car's performance during a session, especially if they're driver adjustable.
Okay, so the loophole, the argument the teams would need to make, it hinges on how the system is implemented and controlled, right?
Exactly.
The source mentioned a crucial condition, or maybe a set of conditions, for it potentially getting the FIA's okay.
That's right. The golden ticket seems to be if teams can successfully argue and crucially demonstrate to the FIA scrutineers that their system is, and these seem to be the key words, passive, embedded, and non-adjustable once the car is out on track.
Okay, hold on. Passive,
Yeah.
embedded, non-adjustable. But we just established it uses electricity to actively pump heat. How on earth do you argue that is passive or non-adjustable? That sounds like bending the definition somewhat.
Welcome to Formula One regulation interpretation. That's the absolute genius, or maybe the sheer audacity of operating in these gray areas.
Okay, break it down. How could they argue it?
Well, embedded is maybe the easiest argue. It's physically integrated into the wheel structure or the brake duct assembly, a fixed part. Non-adjustable could mean the driver has no button to turn it on or off or change its setting mid-lap. Maybe the control logic is preset before the session, or it's triggered automatically by existing sensor data like brake temperature, rather than direct driver input.
Okay, I can sort of see that. But passive, that still feels like the big stretch.
That's the trickiest one, absolutely. The argument might rely on defining passive in a very specific regulatory way, perhaps arguing that because it's embedded within a larger passive structure like the wheel, or that it passively reacts to the thermal conditions around it even though it uses power to react, it meets the definition. It's all about how you frame its function against the precise wording or lack of precise wording in the technical regulations.
Wow. Okay, it's not about the physics. It's about the legalese. It's arguing its mode of operation fits whatever definition of passive or non-adjustable the rules currently allow or don't explicitly forbid.
You've nailed it. And the fact that it might be legally possible, even if it requires some creative interpretation, especially for 2025, before rules potentially get tightened later, that's precisely why teams would be pouring resources into figuring this out right now.
Absolutely.
Right.
Because if there's even a sniff, as you said, of a legal pathway to a genuine performance gain like this,
every competitive team will be all over it. Which brings us neatly to why any of this matters to you, the person watching the race weekend. Why care about Peltier devices and regulatory arguments?
Right. The bottom line, what's the potential impact on track? If a team, or maybe multiple teams, manage to develop this and get it past the FIA legally for next season, what could we actually see changing?
Well, based on what the sources suggest, the potential impact is huge. Really game-changing. Imagine one team consistently keeping its tires in that perfect temperature window, lap after lap, regardless of safety cars or traffic or track evolution.
Okay.
That could mean extending tire life significantly by preventing that overheating cliff we talked about. It could mean maintaining much better grip consistency throughout a whole stint.
Which gives them way more options on strategy, right?
Yeah.
Pit stop timing, stint length.
Exactly. More flexibility, maybe enabling different strategies altogether. And ultimately, it could deliver what the source material flatly calls a significant edge in performance over competitors who haven't cracked it or can't run it.
It really just highlights, again, how F1 operates, doesn't it? That relentless pursuit of performance constantly pushes right up against the boundaries of the rules, actively searching for those gray areas to exploit. You can bet that if this looks even remotely viable, multiple teams are burning the midnight oil right now, not just on the engineering to make it work,
but also on the legal arguments, the presentations, the data they'll need to convince the FIA that their specific implementation meets those passive, embedded, non-adjustable criteria.
It's F1 innovation in its purest, most fascinating, and perhaps most controversial form, finding the edge, technically and regulatorily.
Absolutely.
So let's wrap this up then. We've taken a deep dive into the potential use of these things called Peltier devices in Formula One. It looks like a feasible technology, technically speaking,
Established tech in other areas.
offering this intriguing dual functionality heating and cooling for potentially real-time tire temperature control during a race. And based on the material we've looked at, the really exciting part is that it seems to currently exist in one of those classic F1 regulatory gray areas.
Yeah, potentially opening the door for its use as early as the 2025 season.
If, and it's a big if, a team can navigate those tricky engineering hurdles we discussed, placement, power, heat rejection.
And crucially, successfully argue its legality to the FIA, probably by framing it very carefully as a passive, embedded, non-adjustable component despite its active nature.
If they pull that off, it really could be a significant performance differentiator on the grid next year. A genuine game changer for whoever gets it right first.
It really could.
And that kind of leaves us and you with this final thought, just sticking to the sources we've explored. Given that massive potential performance prize, and knowing the specific regulatory tightrope they have to walk passive, embedded, and non-adjustable during a session, what incredibly creative, maybe even slightly counterintuitive engineering solutions might teams be cooking up right now in total secrecy, purely to make this active heating and cooling technology appear to fit those very specific FIA criteria?
It's a classic F1 puzzle, isn't it? The engineering challenge married to the regulatory challenge, watching for clues next year, seeing if anyone suddenly has tires that behave very differently. That's going to be absolutely fascinating.